Another draft physics presentation. Yay. Anyway, it's same old story. So this is a Veritasium video. So it's linked by Michael Falwell. Anyway, I can show the link later. Sort of linked anyway to a video on water droplets and how they resist coalescing sometimes. They essentially can bounce off of water. Water can bounce off of water. That led me to this Veritasium video that I believe I've seen before. And so this is in little beads of silicon. You can pull silicon out of liquid silicon and it'll float, essentially. A little bead will float on the surface because it bounces. And it's bouncing off of its own disturbance in the medium. So say it goes into the medium, it creates a wave that doesn't transmit very well, and when it comes back down, the wave essentially is still there, and it hits the surface of its own wave and ends up bouncing forward, and then can move forward because it keeps bouncing off of its own wave front. So where it hits the wave is really what this is all about. It's the bubble survives longer if it falls into the surface is going down, then the bubble will survive. The surface is going up, then the bubble will get killed. That kind of logic. Anyway, so this silicon experiment, they use it to talk about the two-slit and try to make this into a quantum effect and show some sign of similarity. And this just shows how this is they're just deliberately forcing this this evidence, and this is just an example of how this is just the evidence is so weak, and they're just forcing things to fit. And this is an example again of just a huge cheat of force.
Calculate the probability of where the electron is likely to be, and then when you detect it at the screen, the electron pops up at one point at random that was in that distribution. We say
this is just explaining the two-slit with electrons, and again their claim is that it goes somewhere randomly. Okay, it doesn't have anything to do with how close it is to the edge of a slit. It doesn't matter how close it is, doesn't matter how far it is, wherever the photon goes in, it just randomly goes to one of these locations. Wrong.
That its wave function collapses instantaneously at the moment of measurement. You can't say that the electron was there before you measured it, and you can't even say that the electron must have gone through one slit or the other. Compare that with the picture provided by the bouncing droplets. In this case, the pilot...
Okay, so now they are using these bouncing droplets and creating a slits circumstance of some kind. And, it's just kind of obvious what happens here, and his claim is nothing to do with what's obvious.
It goes through both slits, but the droplet only...
So the wave, he says, goes through both slits. Now there's no evidence that any wave really did go through both slits, because as you can see, the wave doesn't travel very well. It doesn't travel very far. So anyway, play some more.
It goes through one. The droplet is pushed around by...
There, now watch this one. See, now there's barely anything going through this other slit. There's no wave interference. Clearly this droplet was closer to this surface. The surface meant that the wave got compressed, and the compression of the wave means that when the droplet comes down again, see, the droplet's bouncing up and down. You really don't get that idea, but when it came down again, it's coming down on the steeper slope, so it's bouncing more in that direction. So in a sense, it's hugging surfaces. Surfaces would mean it would bounce towards the surface, and you can definitely see that effect here.
Interaction with the wave.
Now, you can see that it didn't interact with its own wave. It clearly hugged the surface and that's what changed its direction.
So that the resulting statistical distribution is the same. The droplet never exists in...
See, now watch, see, again, comes in, and this one does not, they can't make them come in straight. They don't have apparently the power to do that. But again, watch.
Two places at once.
Watch. So that one came in on an angle and ended up coming out kind of straight.
And there's no randomness.
See, this one gets really close to this surface. So let's see. Tendency would be go this way. How would the wave going through here have anything to do with this one going this way?
There is an answer.
You see how sharply that one turned? I mean, I should have used the mouse to illustrate. Very sharp turn. You know, hopefully I have the right. Yeah, I do. Good enough. Okay. So one more.
It's just due to our...
Oh, see that big turn there, close to the surface, big hook and turn. No wave going through here. The wave here didn't cause this. It's clearly how close it gets to these surfaces will dictate which way it goes.
Ignorance of what's going on. It's not that it doesn't...
Look at that big hook there. Let's play that one again. Big hook there. Too bad they don't have slow motion here. That would be helpful. We'll go back to here.
And there's no randomness. If there is any uncertainty, it's just due to our ignorance of what's going on. It's not that it doesn't
big
exist.
hook there.
So pilot wave dynamics...
So, you know, and then they claim that with those huge hooks, they're claiming it's the same pattern as the two-slit in light or something. I mean, obviously those big hooks mean no, it's nothing like it. So they've obviously distorted the perspective to make it look like it's the same pattern. But it's not the same pattern. So again, trying to just gear this up, like somehow this is illustrating quantum mechanics. And this mechanics has nothing to do with quantum mechanics. No relationship whatsoever, and they're just forcing it. They're forcing something else that has a tiny little wave in it to, again, try to make everything into a wave phenomenon, when clearly it's a mechanical phenomenon that just has to do with the fact that the distribution of pressure will be changed based on how close you are to a surface. That's all.
Can produce many of the same results as quantum mechanics.
See, many of the same results as quantum mechanics. Yeah, so again, just trying to make it seem like, yeah, so this wave thing works, this pilot thing works.
Does this mean that this is really what quantum particles are doing? No. But I think...
Yes, no, but I'm going to try to imply as much as I can that quantum particles are just like this, because they're creating waves around everything.
It'll at least suggest that this is possible. These are possible dynamics that could lead to the statistics.
Okay, so it's not, but these are possible. So again, you know, the contradiction right there. Is this the way quantum mechanics works? No. But it's possible. You know, what's the point?
Which are captured in the quantum mechanical theory. And what's appealing about this is it gives you a clear idea of what's going on. You don't have to abandon the idea that the universe is deterministic.
Yes, but you do have to just pretend that you didn't see it one way and he described it another way, where the wave went through the other slit and somehow caused the effect, when clearly what happened in the other slit didn't have a damn thing to do with where that little water droplet was going. It had to do with how close it was to the surfaces.
You get particles with definite position and momenta. I think it's great that we have two competing theories for the same experiments. And they both ask you to accept odd things, just different odd things.
Oh yes, that's great. It's great to have science that contradicts itself. It's just brilliant. Yes. That means you have the right answer. When you have contradictions, those are great. But that means you're right on the right. That's what you're getting warmer and warmer, when you have more and more contradictions. Fuck.
It comes down to what you're comfortable with, really, whether you prefer.
Oh, that's what it comes down to. Oh, how do I feel about it? You know, it doesn't come down to logic and some sort of integrity and not exaggerating the evidence.
The Copenhagen interpretation of standard quantum mechanics or a pilot wave theory.
Right, like they're somehow dramatically different. Copenhagen basically is a pilot wave theory. Copenhagen is radar.
Let me know what you think in the comments. Do you like the pilot waves? I mean, it's definitely a very appealing picture. Whether or not it corresponds to reality, that remains to be seen.
Yes, well, 1 minute you said no, and now it's 1 minute to remain seen, impossible. So we have all kinds of choices we can make about whether or not this should be considered applicable in some way. When clearly, if somebody honestly viewed the experiment, they'd say it doesn't have anything to do with it, because those phenomena are all based on some sort of idea that doesn't matter where the photon goes through. Doesn't matter. It goes here, goes here, goes here. It has the same random probability. And clearly what demonstrated in the water droplets is, no, it does matter. Close to the surface, bend a lot. Far from the surface, bend none. Yeah. So more, just more of this greatest theory ever. It's so reliable and so perfect. Yeah, if you're willing to manipulate the truth, if you're willing to play games with the truth. So quite pathetic. All right. So let's see. Where do I want to move on to? I sort of wanted to get to this idea of weak evidence. I want to get to some kind of like 12-step videos or something. Where step one is you got to admit the evidence is weak for all of these hard conclusions. And if you can't do that, then there's no conversation for us to have. If you think this is strong evidence, I think you're lying, or you're insane. If you can't tell the difference between the evidence proving evolution and the evidence proving quantum mechanics or relativity, bent space thingies, time dilation. And look at that, the color's off again. Strange. Oh, I should have fixed that, I guess. I could have fixed that, I suppose, but I didn't. So, I don't know if it's too late to fix it now. It's like, what's the point? Swap. Okay, we'll see how that works. Yeah, blew it up altogether. So that didn't work very well at all. Now it's showing the wrong window. Right? Yeah, that's the wrong window. How did it change the window? I didn't ask it to change the window. Huh. Sneaky fucker. So I have to find this one. Yeah, that's where it was. Okay. Don't know exactly how that happened. So anyway, to the comment section, I suppose. Whoa, got bigger for some reason. It's the size it should have been. Yeah, I don't know why. Well, whatever. Alright, so this is the Michael. Maybe I'll go back to that video actually, because then I can show the. It was an interesting video. Thanks for the link. It was interesting. I don't know if it's applicable to anything, but it was interesting. And this doesn't go back, so I must have gotten there from somewhere else. I guess it's this video. Ah, here we go. So some of this is really, these little water droplets in slow motion camera.
Crashing into the drop like I anticipated. It's almost like those peaks and valleys make some type of moving catcher's mitt that gently catches the drop and lets it down gently without breaking that air layer. Now I want to zoom in and see if we can see that wave catch the drop.
I mean, it's kind of amazing photography. I have to get one of these $100,000 cameras someday.
It's pretty clear what's going on here. Think about it this way. If somebody threw you a water balloon, would you rush your hand up and try to meet it really quickly and risk bursting that surface tension? No. You would try to match the...
I mean, I don't know why this guy is so... it's just such a... just not very intelligent.
Here that Don Pettit launched to the International Space Station, where he accidentally recreated the phenomenon in a really remarkable way. He performed a very similar water speaker experiment, except in weightlessness, the water forms a sphere. Just to make it interesting, Don put an air bubble on the inside of that water sphere, and then he played tones through the speaker just to see what would happen.
And the air bubble is attached to the speaker cone, and so is the water. And I'm at 60 hertz. I'm going to start increasing the amplitude. Here we go. Wow. So we're getting a series of standing nodes on the interface of the air bubble with the water. I'm going to put a square wave in.
So, kind of neat, right?
Okay. Triangle wave.
So Don played with different frequencies, amplitudes. He played...
This was cello music, does it?
This video sets my brain on fire. We learned two main mechanisms for coalescence. We have the weight of the drop that squishes that air boundary and makes it go.
Why didn't you just play more of that? This is better than this one here. So anyway, so you can see the little droplets move quicker, the big droplets move slower. It's sort of an obvious thing. But anyway, quite interesting video. So anyway, what else? Yeah, so now back to the comments. Oops, wrong way, this way. There, okay. So this was Michael Falwell's, entitled, yes, Mystery of Walking Water. Anyway, that was pretty good. Maybe I'll deal with some of these comments, I guess. Whatever. I just shouldn't bother with the commenters. Some of them, anyway. I would like to hear your explanation using a much better graphic of the magnet with its field lines. I guess I should see what video this is relevant to, but I don't think it's it's a Ken-Wheeler responder. Field lines are sort of an illusion. They're only a real magnet will just pull everything towards it, right? All the little magnets will just go towards it if you just have them in open air. So to create the illusion of field lines, you have to create an effect where the magnets can't get to the other magnet. And so what's really happening, let's see if I can draw it or not. Try drawing it, what the hell. Let's see, that should open the draw. Yes, it did. So, and then I should be able to go to the drawing program, wherever it is. It's probably this one. We'll see how this goes. So the idea would be, so here you have a magnet. Let's just make a magnet in here. Really crappy magnet. Yeah, it's cheap. I got it on eBay. And so we have these field lines that are supposed to go something like this around the magnet, blah, 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 blah. Alright, now, if it was in the real world, there wouldn't be any of these field lines because all the magnetic material that's creating the field lines that you get to see would just go into the magnet. Because the field lines are just made out of little magnets. So you got to think of the field lines are just made out of a bunch of little magnets, and they all have to line up north, south, north, south, north, south, north, south to be able to stick to each other. Well, to be compatible with each other. And what's basically going to happen is they're going to line up and turn into one big magnet in a way. Okay, one big magnet. And the big magnets are all going to have the same, they're all going to be lined up exactly the same. That is, this will be the north side, let's say, for the sake of, well, that's not very good. And this will be north, and we'll just put an arrow indicating north. And then this magnet will also be, this will be its north end, so to speak. So it's made up of a bunch of little magnets, all pointed exactly the same way. So they're all lined up the same way, because it's north, and then the south end has to be facing the north end. So the north will always be pointing in that direction. So the reason why these field lines form is because the little magnets can't get to the big one. They can't just go, you know, this piece of paper in the way or whatever you're using to prevent, you know, to cause it so they can't attract. They can't pull into each other. And what basically happens is you form, the little magnets can't get to the magnet, but they line up in the same way as the magnet, and you end up with a bunch of magnets repelling each other. Now, this is probably wrong in the sense that this should be the South Pole. Okay, sorry. And these will all be north, north, north. So the energy comes out of the magnet in straight lines, and what's happening is, I guess I could change the color to do the red, right? Yeah, I could just go like that. So you have two different kinds of force coming out. So, and then there's a little bit of red sneaks this way, of course, and then a little bit of the black sneaks this way. And the magnets are lining up with that, the strength of that pole, in line with the strength of that field. So, and that's what they're trying to do. And so that's why this is going to end up being the opposite of this magnet, because these magnets are all going to turn to attract. They're all going to flip to try to attract to this magnet. So they'll have they'll line up strong and try to they're trying to make their attraction the strongest and their repulsion the weakest, and that's what flips the magnet. So it'll flip to the opposite orientation and create a big magnet of that opposite orientation. You can sort of understand that these field lines are basically repelling each other. So that's why the field lines don't crash into each other, because they're repelling each other. So all the field lines are basically repulsive to each other because they're forming one big magnet. And so that's why there's field lines. But it really just has to do with this energy coming out in straight lines that creates the attraction. These lines are what flips all the little tiny magnets in the right direction. Right? See, when you're halfway between the north side and the south side, or the south side, as this one is saying, in the north side here, you can kind of understand that the repulsive pressure and the attractive pressures are all balanced, and so you line up straight. and then your line, you start going a little crooked as your strength of your south to north strength is a lot stronger than your north to north. You know, the repulsive force is weaker than the attractive force, so there's less of a balance. So you start to just turn in facing the magnet as the force hits you. So the balance of the force decides what orientation you have, like this versus this or this. You know, what alignment you have just has to do with how much pressure you're feeling, how much repulsive pressure versus how much attractive pressure. And obviously there's always kind of, you know, this south end is obviously, if there's a little tiny magnet right in here, the north end and the south end are going to attract, but the south end and the south end are going to repel. And the north end is going to be a little tiny bit closer than the south end. And if the magnet can flip this way, you know, where, you know, that's what it does at the top. So it basically flips, so the magnet lines up north-south. Yeah, not drawn very well, but yeah, it's better than absolutely nothing. Okay, so yeah, that's enough bad drawing. I have to get rid of the bad drawing and switch back to the comments. There we go. Not just, you know, it's almost efficient. Alright, so that was the Michael comment I already did. So we'll move on to the gunslinger, who no doubt is John the fucking Wayne, or whatever his name was. Maybe those slit images are rounded because there's an intensity drop off horizontally and vertically. The point is the math doesn't indicate that. As he just pointed out, quantum mechanics, sort of the rule is that the location of where the quanta go is randomized, okay, and just probabilistic. And there's nothing in the probability that says it should be at all curved. It should be dispersed evenly, not evenly. It should be dispersed to create the wave pattern, and that's it. No other dispersion is built into the math. So I'm just saying it's a feature completely unexplained and uncovered by the math, and it isn't consistent with their probability math. Alright, the math is only done in 1D or 2D. Well, that's irrelevant. So there's no, you can't use that excuse. It's done in reality. And so you're not allowed to just pretend that because it's you see it in one dimension even, that somehow that changes the fact that everything's in a three-dimensional universe and functioning that way. There's nothing 1D or 2D about the math. Alright, and someone could probably do it, but you still keep using the same arguments. So I keep using the same arguments when somebody could do something you haven't done, which is indicate how that's theoretically relevant. So you still haven't, there's just no explanation. You say you have perfect math, and I show where your math isn't nearly perfect, far from perfect, and your excuse is you'll keep saying it's far from perfect until we prove otherwise. Yeah, that's right, that's what I'll do. About the slit width, alright, so same arguments about the slit width, like the dishonest fuck that you are. So somehow I'm being dishonest by pointing out what you're promoting as a truth that isn't true. You're making claims about a whole bunch of things being true. I'm showing how the evidence doesn't indicate they're true. And now I'm the liar. I'm the dishonest person, when you're the ones making the false claims about the strength of your evidence. So why should anyone bother? That's right. Just slander people who rightly do the right thing and say it doesn't match. Say that the honest impression, the honest interpretation, fuck that person, he's a liar, because it's against your God. I mean, you're so despicable. Gunslinger. It's been explained to you already many times, so at this point you are making a lie by omission. So again, what has been explained, I'm not kidding time codes on videos. You have to be able to be an adult and actually make your argument by quoting somebody. And if you want to provide a time code just so you get somebody can see the whole quote, fine. But to do this stuff, what are you, stupid? I should make my arguments that way and force you to rewatch videos? Fuck you. Silly. Now you say that the stuff in Mach gravity has to be absorbed. I've always argued that the force is absorbed. That's how something gains speed. If gravity is moving you, it's because you had to absorb a force to be moving. I mean, you don't believe in those simple force laws anymore? You've gone that far where you don't even need a force to act on something. It can just all of a sudden go. It doesn't need to absorb any energy. But that energy has to go somewhere when you have bodies in orbit. Well, the bodies in orbit, guess what? They don't ever really go anywhere. They don't get any closer to the sun, do they? And they don't increase their velocity of their orbit, do they? So, in a sense, they're not really absorbing, but for a short period of time. Let's see, it's only one thing to say that all that absorption goes into kinetic energy. Again, it doesn't go into any energy, in the sense that the only velocity the Earth has, it's the velocity it brought into the orbit. It's not moving in any other direction, really. But it's another thing to see whether that pans out, especially when it's in a circular orbit. Can you understand? One minute it's going this way, the next minute it's going exactly the opposite way. You see? So those are opposite tons, you see. So you start giving back the exact opposite of what you took, then you go back to neutral again, asshole. Anyway, but it's another thing to see whether that pans out, because gravity can also slow objects down. Gravity can slow objects down. Gravity is always conservative, so if it slows something down, it has to speed it up somewhere else, unless you stay in the gravity. So if you're gonna go in and then out, you're always going to get and lose. You're never going to, you can't win, quote unquote, from the gravity itself. You can only go in, gain some motion by the object you're staying with for a while, and then leave. Then you can keep that motion. You can keep some other motion that the thing with gravity has. You can steal some of that motion, but you can't steal the gravity. Idiot. Anyway. Some more time codes. There we have it. You replied to the fucking sentences out of context. Again, so you can't be bothered to provide any indication of what you're saying I took out of context, except forcing me to go rewatch a video. No, that's too lazy, asshole. Fuck you. Let's see. That's when happens when you respond to small snippets of a thought and not the entire thing. It's a tactic of his. So there's some sort of tactic where I respond to videos and somehow I've pre-engineered it to use some sort of tactic. So you people, the people listening, you're too stupid to see that I used a tactic. And that somehow I'm not honestly reacting to what I think somebody said that's absolutely horseshit. It's amazing. Allows him to think he's winning when in reality he's not even arguing against what the person is actually saying. Yeah, I thought I blocked you, asswipe. That must be some other douchebag channel he's got now or something. He's the, climate change is a lie truther. So first I have to go back to this video, and then I gotta go 30 minutes into it. Okay, so just for you, you piece of scum. We'll waste time doing this. Let's see, 30 minutes. So we'll see this great and horrible, tragic, horrible thing that happened. And that happens all the time, right? The whole video is just this misunderstanding stuff happens all the time. I'm the only one guilty of it. Misunderstanding what somebody was saying. Oh, yeah, I'm the one who does it all the time. course is so pathetic. Alright, 30 minutes. 30 minutes, 30 minutes, 30 minutes, 30 minutes. We'll go back a little longer than that. There's no doubt this asshole has quote mined.
Einstein equation, and the only flaw in it is this problem of acceleration and velocity in free space.
So right there I'm talking about the fact that Mach gravity works perfectly in all the gravitational sense. And the only thing that breaks is when you take, when you have to move, like say an Earth through free space. If this force existed, the theory is it would create friction. Now I've explained the friction problem, so it doesn't exist anymore, but I'm just saying that was the classic problem with Mach gravity